I want to do another example of the confidence interval of a single proportion, right, using these guys here. And that's really like an overlap from last time. And then I'm going to move on and I'm going to use some real life data that I collected on COVID. And we're going to use it to compare two groups to see if statistically there's any significance between the two, right? So this one here is just going to be a made up story. So I have no idea what this made up story is going to be, and I'm running short of data to do it to. So let's ask you lot something. And I've got you on the screen. So you're going to vote with thumbs up thing. And the question is, if you want to say yes to this question, you stick your thumb up. And if you don't say anything, I'm assuming that you're a thumbs down. So there's 2, 4, 5, 10, 15, 20. So there's going to be 25 in this sample, which should work, hopefully. And what am I going to ask? How many of you have been to a restaurant in the last week? 1, 2, me is 3. Next column, nobody. 4, 5, 6. Okay, that'll do. Right, so I want to find, based on some very dodgy assumptions, but just for the sake of argument, that you lot are a fair representation of college people, right? People who are at college, either teaching or are students. And we are going to use your data to estimate what percentage of college students have been to a restaurant in the last week. We've collected the data, and all the assumptions are probably not true. We're pretending that they are, like you are a fair representation, and that this was a good random sample. So convert that guy. I don't know why I'm using my calculator. I guess I'm getting tired and I'm frightened to make a mistake. But 24% of you said yes, but we would like a confidence interval to see what kind of range the population parameter might be. Any particular number you want me to try out? 90, 95, 97? Would you want, 97, 99, something like that? What do you want?
95.
95 it is then. Q hat, I'm just writing down the values of things, is 76. And since it's going to be a 95% confidence interval, we're going to use that Z value, and that's 1.96. I also will need the standard error. So that's going to be P hat. Oh God, there, I should have said Q hat, but too late now. P hat, Q hat over N. So the ones that said yes, 24%. The ones that said no, that's Q hat. All over, very small sample size, which is 25. And on my calculator then, square root of 0.24 times 0.76 divided by 25, and the answer I got is 0.0. Well, let's just make life easy to 2 decimal places, right? Essentially 9%, right? So you put the package together for a 95% confidence interval. That's that guy. In this case, it's 0.24 plus or minus 1.96 times 0.09.
Got an email to Leanna's in the waiting room.
Thank you. Got it. Right. So we have this fella plus or minus 1.96 times 0.09. And we are looking at, again, I'm just being really very strong rounding off here. Essentially that guy. that would correspond to 24%, give or take 18%. And if we looked at that as a takeaway, it could be as low as 6%, but it could be as high as 42%. So our 95% confidence interval based on this sample is huge, as you would have expected. 25 people ain't going to cut it, right? Now that I've got that guy, it's going to allow me to do some changes to the world and see how it affects this interval. So I guess I should keep my intervals kind of information together. So this was a sample size of 25, and it was a 95% confidence interval. And it ended up anywhere between 6 to 42%. So what I'm now going to do is I am going to pretend that it wasn't 25 people, but 2,500 people. But we're keeping the rest of the world the same, right? Now, what is going to be the effect on all my data? Well, since that's the same, won't Q-hat be the same? Won't the magic number be the same? In fact, the only number that's going to change right now is going to be the standard error. Well, this standard error, before I do the calculation, do you think it's going to be bigger or smaller than this 9%? What do you think? Bigger or smaller? Can't hear answers, but I think I can lip read a little bit. It's actually going to be smaller, which I'm going to round off to 0.01. Now, if you look at it, it's 10 times smaller. But the data is 100 times bigger, which seems slightly out. 100 times more numbers, but only a 1/10 of a reduction. So it's not a 1-for-1 deal. In fact, the deal is a square. So if you multiply your data by 4 times, right? So you ask 4 times as many people. Do you know you only half the standard error, right? It only reduces by a half. If you did, I don't know, 36 times, right? You increased your sample size by 36. You would only reduce the standard error by 1/6. So there's a kind of law of diminishing returns here, right? For instance, if I increase this by 1 million, right? 1 million, I would only reduce this by 1,000th. So can you see why there's a kind of a cost restriction on making huge sample sizes? Because you may spend 10 times as much money, but all you get out of the benefit is maybe this is 1/3 of the size, right? So if you're interested, the normal going rate for pretty much every commercial sampling company like Gallup Poll, right, all those ones, the normal going rate for them is about 1,000 and change. They always have a few extra in case somebody refuses to answer or whatever, right? So it's about 1,000 and change, 1,020, 1,012. And that's typically what every company does. That's kind of the biggest balance between cost, because finding 1,000 people and asking them costs money, right? But not spending so much money on a huge group and not really getting a lot of numerical benefit. Now, what's that going to give me as far as this fella's concerned? Well, that number's the same. That number's the same. And this guy is that fella. So you're now going to get 0.24, give or take nothing, 0.0196. And I'm going to turn that guy into 2%. Now you look at the comparison. If you increase your sample size, but everything else stays the same, do you notice that your interval is much smaller? The margin of error, which is this guy here, right? The plus or minus 2%, is smaller than the margin of error here. And that is a truism. That's true all the time, right? So if you want to get a nice tight interval, right? Something that gives you something meaningful, right? Because that's a pretty meaningful range, right? Then you need to spend the money, right? You can't do it with 25 people. If you try and do anything with 25 people, trust me, the answer is always going to be a huge interval. Just is. You're never going to be able to get around that problem. Now I'm going to keep the 25 and do one last change. I'm not going to do a 95% confidence interval. I'm only going to do a 90% confidence interval. So that one's got nothing to do with this question right now. Damn thing's never going to stay put. Now, hide that. If you keep the sample the same, right, and the answer's the same and everything stays put, and the only thing you change is your confidence interval, will this new 90% confidence interval, will it be bigger or smaller than this one?
Smaller.
It's going to be smaller. If you're only 90% sure, won't you have fewer numbers in your interval? Because you're only 90% sure. So let's check out what that ends up looking like. I can do the calculation here. It's p hat plus or minus the magic score for 90% and the standard error p hat. That number is not changed in this situation. The z-score did change. That magic z-score is now going to be the 1.645. But the standard error, because nothing else changed, is still going to be 0.09. And now we have that fella. So we got 1.645 times 0.09. And that's going to be give or take, I'm going to call it 15. And so now it could be as low as 9%, but it could be as big as 39%. And just as we predicted, can you see that the interval has shrank a little? Right, that's the first one we did. Do you see that is going on? So what this tells us is that there is a direct connection between the confidence interval that you use and how big your interval is going to be, and the size of your sample and how big the interval is going to be. And we tend to talk about the interval, but we also tend to talk about the margin of error because it's a little bit easier to do. So when it was 25, the margin of error, 25 at 90%, and then 25 at 95%, and the last one, which is 2500, at also 95%. The margins of error are as follows. It was plus or minus 2% on that one. It was plus or minus 18% on that one. Oops. And it was plus or minus 15% in that one. So you can imagine you're going to get a homework question where it might say something like, suppose you increased your sample from 200 to 400, what would be the effect on the margin of error? And the answer would be things like it gets bigger, it gets smaller, it stays the same, or not enough information, right? That kind of A, B, C, D kind of choice. And the answer will be, if you increase the data size, won't the margin of error reduce? If you reduce the sample size, won't the margin of error increase? It's like a seesaw, you know? As one gets bigger, the other gets smaller, right? Like a seesaw, right? One goes up, the other goes down. One goes down, the other goes up. That's a very straightforward relationship. And then you can talk about confidence intervals and their effect on the margin of error, right? If you increase the confidence interval from 90 to 95 to 99, doesn't the margin of error also increase? At 90%, it's this. At 95, it's this. At 99, it's that. That's another truism. That happens no matter what the data is. So the kind of the end of single sample questions. Somebody try again here. So I'm not going to show you. I hope I've got it on screen. It better be, because if I don't, I'm going to be annoyed at myself. And here we go. Let's actually do some real analysis on real data, right? Rather than me making up things or asking you, did you go to a restaurant, right? So this one here just struck me as quite interesting. What we have here is, what's the site? The COVID tracking project. So I'm pretty comfortable that this is good data, right? It's not just made up stuff. And they have collected information, lots of different information about COVID. But this one is quite interesting. And we're going to compare the death rate from COVID. So per 100,000 people, how many have died up to and including March the 7th, right? So you're knowing you're pretty up-to-date data here, right? It's March the 7th, not that long ago. And we're looking at a death rate as per 100,000 people. So what I'm going to do is I'm going to look at this as if I collected a random sample of 100,000 Black Americans. 178 of them have died. So my first population, I'm going to call it N1, has a sample size of 100,000. And the number who have died, to date at least, is 178 of them. And we're going to compare it against white Americans. And that's going to be my second population. And there's 100,000 of those. And we are looking at 124 of those. So I'm going to be, or we're going to analyze this data to see if that is statistically significant, because it looks like it is. And we are going to look at the classic, is there a difference between these two populations? So you remember, this is the Black population, and this is the white. Now, we've met this formula before. We've met this formula before. We can do a 90, a 95, 98, or a 99% confidence interval, right? So you might say, well, I wonder which one to choose. It really, if you were the person who was analyzing this data, do you know you have a lot of power? Couldn't I decide 90? Right. So if I do a 90% confidence interval, and at the end of that, I say statistically significant, right? More Black people are dying of COVID than white. Right? That's what my conclusion could be, right? If I do a 99%, I could actually maybe not get a statistically significant result. And so the moral of this story, not in this data, but in general, is if something is statistically significant, shouldn't they tell me the confidence interval that they were using to decide that it was statistically significant? Can you imagine a situation where the 95 worked, but the 99 didn't? Can you imagine the intervals change size, and because they change size, you might not get a statistically significant answer with one rather than the other? Would you agree there's probably a very big temptation to pick a confidence interval that gives you a statistically significant result? Because isn't it kind of boring to say, we can't tell? There might be a difference between the two groups, but we can't tell. So you're in charge. What do you want? 90, 95, 98? I hate 98, so I'm not even accepting that. Right, 90, 95 or 99? Which one are you going for?
99.
Right, so if we get anything statistical out of this, couldn't you bet your house on it? Probably. Well, a 1 in 100 chance we're wrong, but good enough. So the process for organizing this is pretty much what you'd expect. There's a guy called, I'm just adding the words, the jargon now. It's called this test statistic. We will assume that these black and white people are totally independent, which I think is pretty, you know, right, they are, right? I think that's a fair assumption. So the test statistic is going to be the difference between these two. Obviously, I should turn these into decimals. Actually, they're not that hard to turn into decimals, but I want to make sure I get the right number of zeros because it's dead easy to screw up. 0.00178. And this fella is 0.00124. And the test statistic is this fella. Take away this fella, which is 0.00054. Now, what that is telling me is that there is a difference, right? But it is a tiny difference. And one of the contributing factors of why it's so tiny is that the percentage of anybody who dies of COVID is less than 1%. It's actually 0.2% at most, right? So you'd expect tiny numbers because two tiny numbers subtracted should be an even tinier answer. So that in itself is not an unusual result. That doesn't make it not significant, right? We don't know anything about that yet. Since we decided that a 99 is a really difficult hurdle to get over, but if you go over that one, you can be really sure that it's significant, right? That there is a clear difference between the death rates. We need to get a guy called the standard error. And does anybody remember this guy's formula? Because it's the same formula we've met before.
P hat 1 minus PQ hat, or P or Q hat 1 over N1, and then plus.
Same thing again with twos?
But with 2, yeah.
Okay. Right. Now, that is going to be some ridiculous calculation. I'm just going to put it into the calculator because if I start writing all these zeros all over the place, it'll just look a mess. So can you pretend that all of these are numbers and I've written them down, but I'm really just going to get the calculator to do it for me. So here goes. It's the square root of P1 hat, 0.00178 times Q1 hat is what's left. So that's 0.99822, all divided by 100,000. Add, now we'll do the same with this one, 0.00124. The Q hat this time is 0.99876. And that's going to get divided by, hopefully I didn't screw up anywhere. Boom. And things like this do happen. Do you see a funny E -4 on that screen, right at the end? You know that scientific notation. So I'm just going to call it 1.7 e to the -4. That is 1.7 times 10 to the -4, which is 0.000, basically 4 zeros, including this 0 here, 17. So that's just going to be something you have to sometimes live with, right? If the standard error is tiny, which it is. Why do you think this standard error is so tiny? And it's not actually anything to do with the fact that these numbers themselves are tiny, although you would think it does. It doesn't actually really get affected much by those values. So they could be big or small. That would still end up being tiny. So what is causing the smallness of this?
Population size
Yeah.
or
these
sample
guys.
size, I guess.
Sample size, really, right? Now, you could change that to 0.6 and do a calculation. It won't be that different from this. It won't really. You might think that's the reason. Well, if you think about it, if this is tiny, isn't the Q going to be big? So they kind of balance each other out, don't they? Right. So I got all the pieces. Let's put them together and get our 99% confidence interval and see what we have. So it's going to be the difference between the two, plus or minus the magic z-score and the standard error. This guy is 0.00054 plus or minus 2.576 times 0.00017. In a way, because this is such a real life situation, right? This is real data. Have you noticed that the numbers are never pretty? They've got lots of decimal places to them, and they're not 0.25s anymore, right? When you do real data, you just got to live with the e to the -4s and 6 decimal places, most of them being zeros, right? That's just going to happen sometimes. Now, in this case, it's 0.00054 plus or minus whatever that comes to. So 2.576 multiplied by 0.123017. And the answer that I get is another one of those E guys. So 0.000 and 1, 2, 3, 2 numbers then to keep consistency is that one. And that ends up being 0.3010 and 0.123098. Right, we are looking for statistically significant difference, right? Don't be put off by the smallness of the numbers. That has nothing to do with being statistically significant. This is statistically significant. Why?
Zero isn't covered.
Right. Would you agree that all these numbers are positive? Small, yes, but positive. Since they are all positive, this is statistically significant difference. In fact, isn't the difference that Black people are dying at COVID at a higher rate than white? So if they have an article and they say, look, we need to do something about this, the COVID is not killing people equally. It's not that we want everybody to go up to the black level. Don't we want the blacks to come down to the other people's levels, right? We want to reduce the death rate, not level the death rate, right? So I would assume that would be our goal. So once you've got a statistically significant result, and I'm sure someone's already done this in this article. Okay. I have a window issue. Excuse me for a minute. Right, let's try this again. Let's return to this data and finish off with the part that's not scientific, but more, why is this true? So we know that, and actually the raw data told us anyway, but we know that this is correct. So you could say, what are the reasonings behind it? Because if you know the reason, then you can find a way to, fix it, right? I got to know what the real cause of the problem is before I fix it. Because if I think the cause of the problem isn't the real cause, and I fix the wrong cause, I won't actually improve anything, right? Any ideas? Why is that the case?
I think exposure.
So
meaning
the black
that,
people are, yeah,
that like a lot of Black communities are poor, which means they might have had to work during the pandemic, meaning their exposure is higher.
that seems a reasonable reason. That could certainly be the case. Would you agree that we could look into that and collect data, but I've got a good feeling that could well be true. A lot of the essential services may well have more Black percentage-wise than white, right? And in the hospitals, not just the doctors and the nurses, but aren't essential workers the people who clean the floors of the hospital and the janitorial staff and the delivery people, and I mean everything in that whole group. You could easily say that. I think that would be a good explanation. Any others? Let's just pretend, I'll be a devil's advocate. I don't believe this, but let's pretend that that wasn't the main reason. Just so we can see if there's another reason. Why would Black people die of COVID more often than white folk might?
Care given.
Say again?
Care given. Like
gotcha, right. They might not have access to the same kind of quality of healthcare. They might go to the doctor
who doesn't do everything to save them.
Yeah, too late to save them. Yeah. That could be a reason, couldn't it? You could check that out. Let's suppose neither of these are. Is there any other reason? We're just kind of fishing here for reasons. Anybody got another reason?
For culture. A lot of Black people need to get their hair done, so they have to interact with each other, which it sounds superficial, but it's something you can't understand unless you're in the culture. So they're willing to risk getting their hair done and meeting up with each other for that, and that could cause exposure.
So it's just cultural differences caused by the need to be together for certain reasons.
Correct. Very good way to sum it
up. Okay. So you can see that when you talk about a cause, would it be reasonable to assume that not one of those was the real cause, but a contribution of those three and maybe two others I can't even think of right now, right? And so when you go to fix that, in other words, you want to reduce that, you would have to say, okay, if it's to do with the fact that they're getting more contact, maybe we should be more proactive in getting them vaccinated and getting them looked after quickly. If it's a health issue, maybe we should be offering more healthcare at an easy to locate place, right? So free healthcare, if you get anything that you think even vaguely COVID-like, come in here and we'll give you a checkout, won't cost you a penny, just turn up and you're good to go. I don't know if you could do much about the cultural thing because you really want to change people's culture. that's getting a little bit too personal, right? I would be really against people saying to me, well, the Scottish culture involves drinking and an awful lot of alcohol in social circumstances. That's not good for you, so I think you should stop doing that. So I'm not keen on people telling me what to do. So I don't think other people would be keen on me telling them that that's what they should do. So I'm not going to say, don't get your hair done. I don't think I've got a right to tell people to do things like that, right? That's what if that's important to you, then you should do it. Here's something weird. I'm only calling it weird because I don't know the answer to it. Why are Asians less of them dying than white people? And can we just pretend, I'm pretty sure that that data is also statistically significant. What the heck is going on there?
I think the agreement with mask wearing in Asian countries, masks are not frowned upon like they are here. And so I think in Asian communities, they were ready to mask up right away.
Yes. In fact, I remember watching television programs about Asian countries, and there was no COVID going on, but a lot of them in the cities wore masks as a natural lifestyle. That's what they did. That might just be it. It might be the Asians were already sometimes wearing masks before even COVID hit. So they have a smaller footprint as far as catching. But
Yeah,
you see,
well, I read some article, and I am totally going to butcher this. I don't really remember it, but that it's expected in, like China, that if you are sick with a common cold, that you would wear a mask, like that you would do that for daily.
the rest of the community.
Yeah, daily things for other communities. So I think that would be an absolute reason for this.
But I like that story. Not just the thing. I kind of like good data. I mean, when you see data like this, you can't get politicians too into it because, politicians like to pick and choose who they tell you things. I think this is really good data. And if you know something's wrong and you've got good reasons for why you think it's wrong, then shouldn't you at least try and improve the score, right? Try and get that death rate down. Now, I know we're kind of maybe closing the barn door after the horse has bolted because COVID has already done an extreme amount of damage to lots of communities. But even saying that, shouldn't you still at least make some attempt to do this? And I don't think I've heard or seen that much about fixing this problem. Have any of you heard a push that should get Black and Hispanic and the other larger groups more protected than anyone else? Have you seen anything? It's almost like they collected the data and then just said, oh, okay, and then moved on to the next thing that they did.
I've heard a lot of people talk about the problem, but there's not a lot of action to try and fix it.
Yeah, nobody's doing much. Yeah, that could quite be the case. Yeah. Yeah, politicians tend to do things after the event to make themselves look good. They don't seem to solve a problem early to cause less damage. But what do I know? I don't like politicians anyway, so shouldn't be listening to me. Okay, there is one last thing to talk to you about. So while I'm getting this set up, you lot should be saying hi. Because we are going to, or I'm going to show you, if I can find the darn thing. Here we go. And I'm going to bring this over here, bring that over there. That looks good. Oh, you disappeared. Where did you go? I've lost you. I've lost you. Where the heck are you? There you are. Phew, that was dangerous. I almost closed you off by accident then, and that would have just been a real pain for everyone. Okay, I think it's good to go now. I'll put it on student view, and I'll tell you about the extra credit. And why you get an extra credit. You should be looking at what your homework on WebAssign looks like right now. Is that the picture you're seeing? Okay. Do you notice there's a new guy called 2% extra credit due midnight Sunday? Right. So it is a special homework assignment. I won't call it homework assignment. It's a special credit, extra credit assignment. When you click in it, come on, there you go. It is a bunch of questions that we've done in the last 7 weeks. So it's
So it's a
kinda,
tiny exam.
yeah, but yeah, I guess. But it's different in the sense that if you get 0, your grade doesn't go down, right? So you're not going to suffer from it. But you might want to do it. In fact, I strongly suggest that you do it, but it's totally optional because it is extra credit that you do it. And you've got until this Sunday to get it done. And that's the only deadline for this Sunday. You know that homework's not due until a week on Sunday, right? So you've got a good window of time. It's not going to interfere with your homework schedule. And the reason that you've got this is that there isn't going to be a class on Friday. I've got some plans that I have to do. And so why not, instead of turning up on class on Friday, why don't you do this? You've got that time slot anyway, right? So use it. And hopefully it'll give you a chance to brush up on some of the things that, based on the last test, you're a little bit rusty on. So you need to be a little bit, proactive. Fix things before they become a big problem. And that's about it. Any questions? Right. And make sure you have a look at Ashton's link. It'll tell you how to do the other different extra credit. I'm trying to find it. Here it is. I'm just copying it right now. I'll put that link on Canvas in case for some reason it doesn't work. Okay, bye-bye guys. I'll hang about if there's any questions.